Hey everyone, this lesson is on linear and quadratic inequalities. And if we read what it says here, it says to solve an inequality means to determine all the possible values of the variable that satisfy the inequality. To solve algebraically, isolate the variable, which is stuff that you all already know how to do. So just a reminder though, that when you multiply or divide by a negative quantity, you must always flip the inequality sign, okay? Now, the next question says, what's the difference between and or? There's a big difference. So and means that everything must be satisfied. So every condition must be true for the statement to be true. Okay, but for or, if we have the word or in between, what that means is only one condition needs to be true. However, we can have more than one statement that is true as well. So we'll take a look at this example here. These examples here. So in question 8 it says x is less than 9 and x is greater than 0. So let's graph this out on a number line. So we'll go from -2 all the way to maybe like 10. And I said that because I just wanted to go a little bit to the left of the smaller number and a little bit to the right of the larger number. Now, listen carefully to this right here. The first one says that x is less than 9. So if x is less than 9, then it would be all of these values right here, okay? But the second one says that x is greater than 0. So this would be all the values to the right of 0. However, because it says and, all the conditions must be true, and the only way that all the conditions would be true is only where the pink and the green here would overlap with each other. So that means that the only places that work are between 0 to 9, okay? So this right here is where I would shade in. So for example, like the number 4, if you look right here, the number 4 is less than 9 and it's also greater than 0, so it works. But for example, like the number -2, even though -2 is less than 9, it's true, -2 is not greater than 0. And in order for an and statement to work, both inequalities have to be true. It's because it has to satisfy both, we can actually write this as 0 is less than x is less than 9. We can only put these together if we have an and statement, okay? All right, so now let's take a look at the next one right here. X is greater than or equal to 1 or x is less than -4. So the smallest number we have here is -4, so we'll go a little bit to the left of -4. And a little bit to the right of this 1 that we have right here. The first statement says that x is greater than or equal to 1. So I would go to the right. And then the second statement says that x is less than -4. But because this is an or statement right here, it doesn't have to satisfy both. So we don't need overlap. So because we don't need overlap, we can just shade in right here like this. And then we would shade in right here like this. Now, because this is an or statement, we cannot put this together as a single inequality. These must be written out as two separate inequalities, okay? All right, in our next example, x is greater than 5 and x is less than 2. So I'll go from 0 all the way up to maybe 6. X is greater than 5 would be right here like this. And then and x is less than 2 would look like this right here. And because this is an and statement here, means that we have to have overlap, but there is no overlap. So what does that mean? It means that we have no solution. There is no possible value of x that is greater than 5 and less than 2 at the exact same time, okay? And then in our last example here, x is greater than or equal to, x is less than or equal to 7, or x is greater than 4. So we'll go from like 2 all the way maybe to 8. So if x is less than or equal to 7, it would go like this. And x is greater than 4 would look like this. And a common mistake people will make is they'll say, well, I should shade in just between 4 and 7. However, because it's or, they don't have to overlap. So this goes on all the way forever here, and this actually goes on all the way forever here. So in fact, every single possible value of x is shaded in, right? Like for example, 5 right here. 5 works because 5 is less than or equal to 7. It also works because 5 is greater than 4. But for example, like if I were to look at 3 works because it's less than or equal to 7. Even though it's not greater than 4, only one of these needs to be true because it's an or statement. Even 4 works because 4 is less than or equal to 7. Even though 4 is not greater than 4, it satisfies just one of these, and that's all that matters. So everything would be shaded in. 8 works because 8 is greater than 4, even though it's not less than or equal to 7. So here, this is going to be, x is actually going to end up being an element of all the reals because all real numbers are either less than or equal to 7 or greater than 4. All right, let's go ahead and do this example here. Solve the following and graph the solution on a number line. So right here, in order for me to solve, I just need to subtract the 3. X is less than or equal to -2. I'm going through this pretty quickly because I know you have done this before. Without any issues. So maybe I'll put like -2 here, -1, 0, -3. X is less than or equal to -2. I will shade in to the left of this value right here, and then that's my solution, okay? If I want to write this in interval notation, it would be from -infinity all the way to -2, including -2. Okay, in our next example, right here in question B, we have to divide by -2. And remember, when we divided by -2, we have to switch this because any division or multiplication by a negative flips the sign. So let's go ahead and graph this out right here. So I'll put -2 here. X is greater than -2, so now I'm going to put an open circle at -2 and shade everything to the right of -2. We've talked in class about why you have to flip the inequality sign, but if you want to talk some more about it, I'm happy to talk to you about it in class. Just ask me, okay? So then right here, this would go from -2 all the way to infinity, not including -2 or infinity. So x is an element of these values here. And here I should have said x is an element of these values as well. Okay, cool. Question C is a little bit trickier. So question C, I want to clear the fraction. So what I want to do, first of all, it's a double inequality. Okay, so this is now, instead of having a left side and a right side, we've got a left side, a middle, and a right side. But whatever we do to one part, we have to do to all 3 parts. So I'm going to clear the fractions by multiplying by 2. And every single part of my inequality is going to have to get multiplied by 2. These 2's cancel, so it looks like this. Okay. So then right here, I can go ahead and isolate the x inside of here. So I would subtract the 1 from everything. So the 1 gets subtracted here, here, and here. And then I would divide everything by -3. So this would turn into a +3 is greater than x. And then this would be greater than or equal to -1/3. But this is not proper notation. Because we always go from the smallest number to the largest number in our inequalities, okay? So then if I want to graph this out right here, I'm going to put 0 here, 1, 2, 3, 4, -1, -2. X is greater than or equal to -1/3. all the way until 3, but not including that 3. And then if I want to write this in interval notation, it would be -1/3 to 3. Now, sometimes these double inequalities can get a little bit trickier. We'll talk about those specifics in class, okay? All right, so this right here says to solve a quadratic inequality, graph the quadratic equation, then visually determine what x values satisfy the inequality. So in this first example, question A right here, x squared is greater than or equal to 9. I'm going to want to I'm going to want to graph out the parabola y equals x squared. And we know y equals x squared is just the most basic parabola. It looks like this right here. And I want to know where it's going to be greater than or equal to 9. So right here, I can take a look at this right here, and this is where 9 is. So I want to know, well, at what x values is it going to be greater than or equal to 9? And we know right here that it's going to be greater than or equal to 9 to the left of whatever this x value is, and to the right of whatever this x value is. So how do I solve this? I need to identify, well, what x value would give me 9? So here I'm going to square root right here. So then here's where things get a little bit trickier, because I'm going to actually set this equal to 9 first, and then I'm going to solve. So x equals plus or minus 3. So we know that these values right here are going to be at -3 and at +3. However, we know here that x has to be, because we want everything to the left of -3, less than or equal to -3, because again, we're looking for where x squared is greater than 9, greater than or equal to 9. So that's anything to the left of -3, or x is greater than or equal to 3, because it's going to be greater than 9 if it's anything to the right of 3, okay? But I also want you to kind of, let's imagine this on a number line, okay? So we know that the special values that this is going to happen at are going to be at -3 and +3. So we know we've got -3 and we've got +3. And then we can kind of test numbers right here. So I can test 0, for example, in x squared is greater than or equal to 9. And so when I test 0 here, I get 0 squared is greater than or equal to 9, or 0 is greater than or equal to 9, which is not true. So that means that anything between -3 and +3 won't work. So now here, let's test a number in this section. So I'll test -4. Well, -4 squared is going to be greater than or equal to 9, because -4 squared is 16. So this section works. And then here I can test maybe 4, which is also true. So this section works. So if you look right here, everything to the left of -3 works, and everything to the right of +3 works. So that's another way you can kind of look at this, okay? So just really quickly, if I want to write this out in proper notation, we're going to say here that x is an element of the reals such that x is less than or equal to -3, or x is greater than or equal to 3. This is in set notation. Or I could say that x is an element of -infinity to -3, combined with union means or 3 to infinity. Okay, all right, let's take a look at question B. B is a little bit trickier. So here, this is going to be we're going to graph out y equals 1/2 times x minus 3 squared minus 5. Well, we know that the vertex of this parabola right here is going to be at 3, -5. So if I were to draw a sketch of this right here, I can go to 1, 2, 3, -5. And I know that this is where my parabola's vertex would be. We also know that the step pattern is going to be, we know that a value is 1/2, so we can graph this out using the step pattern, where we know that this is going to go over by 1 and up by 1/2. And then same thing on the other side, over by 1, up by 1/2. And then I can go over by 1 again and up by 1.5. And then over by 1 again and up by 1.5 right here. And we are looking for where this is going to be less than or equal to -3. So here is -3. We want to know where this is going to be less than or equal to -3. So as you can see right here, from 1 all the way to 5 is where it's going to work, because this is where it's less than or equal to -3. Okay, anything after that is greater than or equal to -3, so that won't work. Okay, so right here we can say that x is an element of the reals such that between 1 and 5. Okay, and then if we were to write this in set notation, x is an element of 1 to 5. Okay. But if you aren't exactly sure what the actual values of x are, you can set these two equal to each other to find the actual x values that work right here. So for example, right here, I would say 1/2 times x minus 3 squared minus 5 is equal to -3. So then I would add the 5 to both sides. Get rid of the 1/2 by multiplying everything by 2. Square root everything. Square root of 4 is plus or minus 2, which means that I would get either x minus 3 equals +2 or x minus 3 equals -2. Well, this tells me that x equals 5, and this tells me that x equals 1. Okay? All right, in our last example in question C right here, I'm going to factor this. So if I look right here, I can see that this is definitely going to be a factorable expression. So again, I'm going to graph out y equals x squared minus x minus 12. And this time I'm going to look and see, well, where is this less than 0? So I'm going to factor this. So this is going to be x minus 4 times x plus 3. So if I were to draw a sketch of this graph right here, I know that I have a root at +4 and a root at -3. I also know that this parabola opens up, so I know this is a general shape of my graph right here. It's going to look something like this right here. And then I'm looking for where it's less than 0. So if it's where it's less than 0, I want to know, well, where is it underneath this line right here? And if you look right here, from -3 to 4 is where it is less than 0. So here I can say that x is an element of the reals such that -3 is less than x is less than 4. Or if I want to write this in set notation, I can say from -3 to 4. All right, one last example. So this says given y equals 2x minus 3, graph the function on the grid to the right. So right here, what I'm going to do is I'm going to graph out this equation right here, y equals 2x minus 3. So we know that the graph starts at -3. This is the y-intercept, right? So the y-intercept is -3, and we know the slope is 2 over 1. So I'm going to go up 2, and then over 1, up 2, over 1, and then I'm going to use a ruler to connect these values together. So here I have y equals 2x minus 3. So the first thing it says is, we've done part A, graph the function on the grid to the right. For x is greater than or equal to 2, determine the range graphically. So I'm going to take a look at where x is greater than or equal to 2. So if you look right here, this is where x is 2. So we know that x is greater than or equal to 2 from here on, right? Like this is where x is greater than or equal to 2. So right here, if I were to take a look at this, I want to know, well, what values of y will work right here? So pretty much all of this is what will work. So what is the range graphically? Well, I can see right here that it's going to be from 1 and above, right? So anything smaller than 1 doesn't work because that's to the left of 2, that's less than 2, so it's going to be from 1 and above. So if I were to write out the range graphically, we would say y is an element of the reals such that y is greater than or equal to 1, or we could say that y is an element of 1 to infinity, okay? Okay, then it says for y is an element of the reals between -3 and +3, determine the corresponding domain algebraically and graphically. So let's find it graphically first. So when y is between -3, so here's -3 on the y-axis, and +3, what values of x are the corresponding values? So we can see right here that it starts at 0, when x is 0, and then this ends when x is 3. So our corresponding domain is going to be x is an element of the reals such that 0 is less than or equal to x is less than or equal to 3, or we could say x is an element of 0 to 3. But let's do this algebraically. So it tells us here that -3 is less than or equal to y is less than or equal to 3. And we also know that y is equal to 2x minus 3, like it tells us this right up here. So I can take this 2x minus 3 and sub it in for y right here. So this would say -3 is less than or equal to 2x minus 3. And then I can say that that's less than or equal to 3. And then I can solve this right here. So I would add 3 to everything. So this would be 0 is less than or equal to 2x is less than or equal to 6. Divide everything by 2, and I get 0 to 3, which is exactly what I have right here. So that's how you can do it graphically or algebraically. And that's it for this video. Let me know if you have any questions.